This conference will now be recorded.
And whereas next coming to the Ionic Cinch chromatography, in Ionic Cinch chromatography there are two types of chromatographic techniques are there, and that are of cation anion exchange chromatography. Here based on the stationary phase, depending upon the charge of the stationary phase, here the components present in the mixture and that are carried with the mobile phase that are separated out. Okay, that means here mainly it is based on charges, hence it is called as the ion exchange chromatography. And in that for the separation of cations or for the separation of anions, here these two types of techniques like anion exchange chromatography and cation exchange chromatography are there. Okay, and also we discussed about what are the applications and what are the examples of this ion exchange chromatography. And next coming to the column chromatography, how can we prepare the column chromatography, and what is the main principle involved in this column chromatography also we discussed. And also we discussed about the flash chromatography, gas chromatography techniques. Okay, and also we discussed the gel filtration chromatography, and this is mainly based on molecular sizes of the components here, and depending upon the sizes here, this causes the separation of the components present in the mixture, and that is the gel filtration. It is also called as a size exclusion chromatography. Okay, up to this I think we discussed. Have you referred the notes, ma? All of you? Any doubts regarding all these topics? If you have any doubts, please post in your chat box, ma, or else you can also personally message me also if you have any doubts regarding these sessions. Because we have no time now, actually the time is less. And we have to cover all the topics, means from the basics I am covering actually. But you have to know some of the information regarding these topics, then only you can understand the whole topics regarding this. Why I am telling all these information means here, if you know the total concept of this information, if that means the matter that is present, if you know the total concept, then only you can answer any type of the question, like the statement questions, like matching questions, like that. Now the questions are asking in different ways. You have to answer that type of questions, means first of all you have to know the major concept behind that, then only you can understand the concept questions. Okay, are you understanding, ma, all of you?
Yes, ma'am.
Okay, good. And then I'm going with the other type of techniques that are present in chromatography, and that are of high performance liquid chromatography, and this is also called as a high pressure liquid chromatography. And this is also a type of column chromatography, and this is also based on the affinity with the stationary phase. And I have already discussed the gas chromatography now, and like that here this high pressure or high performance liquid chromatography is mainly used for the separation of the molecules that are present in the mixture. And this is mainly based on the principle of adsorption of the components present in the mixture onto the stationary phase. Okay, and that means here the higher affinity particles and that are adsorbed for a longer time, and that causes the decreasing of the speed of the movement, whereas the lower affinity, and that means that causes a faster movement, and that allows the molecules to separate fastly. And here, why we are separating this technique from the column and from gas chromatography means here we are using the high pressures, and up to 400 atmospheres are used uh, for the separation of the components that are present in the mixture. And this pressure is mainly used for the allowing of the sample through the stationary phase, and that causes the separation of components that are present in the mixture. Okay, and that is the major principle behind the this HPLC chromatography technique. And you can observe the picture here, and here also we are drawing this solvent into the pump, and here that is mainly introduced with the help of the high pressure, and that causes the separation of the components present in the mixture. And also here the separation of the components that are mainly detected by using a special device that are called as the detectors. Okay, and how what are the steps that are involved in the preparation of this stationary phase, and what are the main steps involved in HPLC means? First of all, we have to prepare the column. This is a type of column chromatography, and that means here first it is starting with the preparation of the stationary phase, and here the stationary phase that is mainly consisting of the cellulose, or else it can be prepared with the silica gel also. Okay, then the sample is prepared by adding the mixture to the mobile phase. Here the mobile phase is mixed with the sample, directly it is mixed with the sample, and then it is introduced into the column from the top, and here by using the high pressure pump, and this is allowed to pass into the container. Okay, and then here the mobile phase then moves, and that can be detected by detector, and that detects the different molecules by using the absorbance powers. Okay, that means absorption of particles, and that occurs at a particular wavelength, and that can be detected by a detector. Okay, and that is the main principle and preparation involved in HPLC. Understood, ma? This is a type of column chromatography first of all, and here what is the difference means high pressure we are using up to 400 moles. Here the pressure is used. Okay, and that is the major points you have to remember. And next, what are the uses means? This is mainly used for the analysis of pollutants that are present in environmental samples, and also for maintaining the purity and quality control of different industrial productions, and also used to separate different biological molecules like proteins and nucleic acids also. Okay, and also, and here we are using the that means high speed is used, high pressure is used, and that causes the faster separation. Okay, and what is the main example of this means? Here this is mainly used for the detection of Ebola, and that means for the detection of antibodies against some diseases like Ebola virus, and like that. And this HPLC is also used for the separation of the plant pigments and plant components that are present, and also for the detection of different antibodies, proteins, like that. Okay, and that are the main uses. And next, coming to the hydrophobic interaction chromatography, and this is also the separation technique, and this is mainly based on hydrophobicity. What is meant by hydrophobicity? And that means hydrophilic is there, hydrophobic is there. Hydrophobic means that is the water hating ones. Here we are using the water hating molecules, and that causes the separation. Okay, and what is the main principle behind this hydrophobic interaction chromatography means? It is mainly based on the interaction between two molecules that are containing the hydrophobic groups. Okay, and whereas the stationary phase, here the stationary phase, and that may be of hydrophobic one, or that may be of hydrophilic, and depending upon the interactions in between the stationary phase and mobile phase, here we can separate the different molecules. Okay, whereas here if we are using the hydrophilic molecules means they can easily interact with the hydrophobic molecules or hydrophobic groups, then we can easily separate. Whereas if the hydrophobic stationary phase we are using means, and that causes different repulsion forces, and that can also be separated. Okay, and here after the reaction here, that means after the interaction, the procedure that is including is the elution procedure, and that elution that can be maintained by using different changing constant conditions like decreasing salt gradient, and also that causes the separation of the hydrophobic molecules. What are the conditions that are favoring the separation of hydrophobic molecules that are used for the elution process? Okay, you can observe the picture of this hydrophobic interaction. Here you can see here, this is the support matrix, and here two conditions are used in a low salt and high salt. And what is happening if interaction occurs means that causing the hydrophilic and hydrophobic interactions, and that can be separated the components that are present in the mixture. Okay, and that is the main procedure or principle involved in hydrophobic interaction chromatography. And for this, what are the steps that are needed means, first of all, the column should be prepared. Okay, first of all, the column should be prepared, and that should be prepared with the silica gel, and that is to be added with some hydrophobic groups like phenyl, octyl, butyl, or else that can be added with the hydrophilic portions also. Okay, and depending upon the stationary phase and mobile phase, here the interactions are taking place, and that causes the separation. Okay, understood ma here? Hydrophobic are they, hydrophilic are they? If we are using the stationary phase as the hydrophilic ones means hydrophobic molecules that are interacting with the hydrophilic ones, and that causes the separation. And like that, if you are using the stationary phase as the hydrophobic ones, the molecules that are present in the mixture containing the hydrophilic ones that are attracting towards the hydrophobic portion, and that causes the separation. And like that, here the molecules that are present in the mixture and that are separated. And that means here this is mainly concerned with the preparation of this stationary phase. Okay, and next, what are the uses mean? This is mainly used for the separation of hydrophobic groups containing proteins, and also this is mainly used for the observation of denaturation activities. That means here protein denaturation, nucleic acid denaturation, how this denaturation is occurring, what is the activity involved in the denaturation processes, and that can be detected by using this hydrophobic interaction chromatography, and also use it for the separation of different organic components containing hydrophobic groups, and also for the separation of hydrophilic and hydrophobic molecules. Okay, and next, hydrophobic interaction examples, and that means this is mainly used for the plant proteins from the crude extracts. That means here different plant extracts containing this antibiotic activity, like that the protein activity components can be separated by using this hydrophobic interaction chromatography. Okay, and next, coming to the ionic exchange, already we discussed in that. Okay, I don't want to go with that. Okay, next, coming to the liquid chromatography, and this liquid chromatography means here the mobile phase that is used is the liquid, and the separation that takes place either in a column or in a plane surface. That means here this is mainly depending upon the mobile phase, which is a liquid ones. Okay, and here also the major principle involved is the affinity. That means the affinity occurs in between the stationary and mobile phase, and that causes the separation. Okay, and here also, that means affinity means higher affinity, lower affinity, same. That means depending upon the affinity of the interaction between the stationary phase and mobile phase, the molecules, and that can be separated out. And also this is majorly based on the polarities, and if two molecules in a mixture that have different polarities, and the mobile phase that containing a distinct different polarity, and that means here the molecules that are separated out with different speeds, and from the speeds and from the movement of the molecules that are present in the mixture, we can detect what type of molecules or what type of components that are present in the mixture. Okay, and that is the main principle involved in this liquid chromatography. One second. Okay. Okay, what are the uses of this liquid chromatography means? This is mainly used for the separation of colored solution and that causing the different bands. And that means here, for example, if two components are present in the mixture and that has to be separated means here, and based on their interactions that are forming different color bands. And based on that here, these are to be separated. And also it can be used for the separation of solid molecules that are insoluble in water, because here we are using the mobile phase as the liquid, right? And that means here the components that are present in the mixture which are insoluble in water, and that can also be detected by using this liquid chromatography. Okay, and this high performance liquid chromatography, it is a modified form of liquid chromatography, and that is mainly used for the detection of different biological molecules. And next, coming to the paper chromatography, and this paper chromatography, and this is also majorly based on the interaction between the molecules and the stationary phase. And here also mainly it is based on the adsorption power. It is mainly based on the adsorption also here. Okay, and here this is mainly occurring in between the mobile phase and stationary phase. I think you know about the procedure of paper chromatography. And here the molecules with lower affinity, they are moving faster, and whereas the higher affinity, these are absorbed for a longer time, and that causes the decreasing of the speed of the movement. And paper chromatography is also of two types, that is of ascending paper chromatography and also of descending paper chromatography. And also this is containing paper partition chromatography, and that means here it is mainly based on the absorption power of the paper. Here, what is the type of paper that is used in paper chromatography means? That is the Watsman filter paper. What's not normal paper here? Here we are using Watsman filter paper, and that causes the separation of the components based on their absorption power. Okay, and that means how these components that are strongly absorbing onto the stationary phase, and based on that only here the separation of mixtures takes place. And this is mainly based on the retention factor. This is mainly based on the retention factor. That means how it is retaining the components present in the mixture, and that is called as the retention factor. And this retention value is majorly used for the detection of the components present in the mixture, and this retention factor is calculated by the distance that is traveled by the molecule to the distance traveled by the mobile phase. How it is traveling, that means for example if some protein sample is applied onto the paper, and at what distance it is traveled and at what distance the mobile phase is traveled, we have to count that, and then from that we are calculating the retention factor, and in that here we have to take the ratio of distance traveled by the molecule to the distance traveled by the mobile phase. And these are mainly used for the separation of the components that are present in the mixture. Okay, and that is called as the paper chromatography. Okay, this is the one here. You can observe the picture of this paper chromatography, and that containing, first of all, we are taking the stationary phase. The stationary phase is the paper, that is the Watsman filter paper. And next here, we are drawing some line and for the application of the components that are present in the mixture. And on that line, we are placing some of the components, that means that may be of proteins, like that here we are adding some samples, and then that is placed on solvent mixture, and that is acting as a mobile phase. Okay, and that causes the separation of components present in the mixture, and that causes the solvent front. Okay, and here based on that, here we are separating the components of the mixture, and from that we can observe different type of components. And here you can see what are the values that has to be applied in the preparation of this paper chromatography. Just okay. Here you can observe here about 2 to 200 microliters of sample solution, and that should be injected at the baseline of the paper, and that is allowed to air dry. Here we apply how much amount of the sample, and that is of 2 to 200 microliters. Okay, and here the sample loader paper, and that should be in the height of 1 centimeter only. Okay, and that you have to maintain these values actually in during the paper chromatography preparation. And what are the uses means? This is mainly used for the detection of purity of pharmaceutical products, and also for the detection of the contaminants, and for the separation of the proteins, and that means for the separation of impurities present in the mixture, and also the chemical molecules that are present in different samples. For the analysis means here this paper chromatography technique is mainly used. I think you have done these practicals regarding this paper chromatography. Okay, and next coming to the reverse phase chromatography, and this is a type of liquid chromatography, and here this is mainly based on the hydrophobic interaction between the mobile phase and stationary phase. The reverse phase chromatography, it is a type of the liquid chromatography technique, and here mainly hydrophobic interactions are necessary for the separation of components are present in the mixture. Here what is the interaction that is taking place means the interaction that is taking place in between the molecules with the hydrophobic groups, and that means here like hydrophobic chromatography, here the same technique is applied here. That means the phases are different here. The stationary phase is solid support, and that should be applied with the hydrophobic and hydrophilic groups, whereas the solvent molecules that containing hydrophobic ones that are interacting with the hydrophobic groups, and that causes the separation of hydrophilic. Okay, and like that here this is a type of hydrophobic. Okay, and that is also called as the reverse phase chromatography. Here you can see the picture here, and here what are the molecules that are binding depending upon the hydrophobicity and hydrophilicity, the molecules are binding, and based on that here the interaction, based on the observation of this interaction here, we are observing the different components that are present in the mixture. Okay, okay, this is the picture you can see here, hydrophilic ones and hydrophobic, like that. That means here depending upon the stationary and mobile phase here, we have to separate the components that are present in the mixture. Okay, and first what are the steps that are involved means, first of all that should be prepared with the stationary phase, and that containing the hydrophobic groups or the hydrophilic groups, and then the mobile phase is added that containing the hydrophilic or hydrophobic, and depending upon the groups of the stationary phase or in mobile phase here, the molecules present in the mixture has to be separated. Okay, and this reverse chromatography, and this can be combined with the HPLC, and that is used for the separation of different molecules, and also for the analysis of drugs, metabolites, and also for the separation of impurities that are present in the environmental samples. Okay, and that is the reverse phase chromatography, and this is mainly used for the separation of the proteins that are present in the mixtures. Next, thin layer chromatography, and thin layer chromatography is similar to that of paper chromatography. In paper chromatography, the stationary phase that is containing the paper, whereas in thin layer chromatography, here we are using the silica gel, and that is mainly used as the this stationary phase. And what is the principle means here? Same like that of paper chromatography. This is also based on the adsorption, that is affinity towards to the stationary phase. Okay, and here the components are eluted with the mobile phase. Here the components are eluted with the mobile phase. Okay, depending upon the reactive sites or depending upon the binding sites that are present in the stationary phase, here the components present in the mixture and that are to be separated and that are eluted out with the mobile phase. Okay, and this is the picturization of this thin layer chromatography. You can observe like a paper chromatography. Here we are taking some glass plate. Okay, and that is the glass or thin plate or aluminum foil, and here the sample is injected as the spots onto the stationary phase, and this is dipped into the mobile phase or it is into the solvent, and that causes the movement of the components present in the mixture along with the mobile phase. That means here elution occurs with the mobile phase. Okay, and that is called as the thin layer chromatography. And what are the uses means? This thin layer chromatography, and this is mainly used for the identification of different substances present in the mixture, and also for the analysis of fibers. Okay, and also used for the assay of pharmaceutical products and for the identification of different plant extracts and their composition also. And these are the some of the chromatographic techniques that are mainly used for the separation. Okay. Okay, ma. And these are the chromatography techniques. And I think have you understood, ma? All of you? What are the main principles, ma? Principles behind these chromatography techniques. These are like similar in similar way, ma, but you have to maintain a like a table like what is the stationary phase when what is the mobile phase and what is the principle in that, and then you can understand easily. Okay, good. Sonakshi, Ganga, Satyam, Asha. What about remaining ones? Ayesha, Ishika, Purnima, Sucharita, Tushar. Have you understood the concepts behind these chromatography techniques, ma? Okay. Any doubts regarding these ones? Yeah, I will discuss the questions, my MCQs also. Okay, I will show some of the questions and also I will send the type of questions in your group. Just a minute, I will show you some of the questions regarding that. Yeah, actually I have shared the notes now, Sonakshi. Yesterday I have already shared the notes. Sonakshi, check the group, ma. I have already sent the notes. Okay, okay. Okay, ma. These are the some of the questions. You can answer these questions, ma. Here I'm giving types, ma. Based on the types, I have prepared these MCQs. You can answer all these questions here, and I have already given the answers also. I will post these type of questions in your group ma. You can practice these questions, and I will show some of the questions in that. Which type of filter paper are mostly used in paper chromatography? What is the type of filter paper ma that is used in paper chromatography? What I said? Yeah, good. Wortman filter paper. Okay. And the pattern on the paper in paper chromatography is called. Actually here this is mainly used for the separation of the components. And this is called as the chromatogram, the picture presentation or the pattern presentation on the paper in paper chromatography, that is called as the chromatogram. Okay. And the next question is the paper chromatography is a physical method, and that is mainly used to separate which type of mixtures? It is mainly used for the separation of complex mixtures. Okay, I like that here. Some of the questions are there, ma. I will share these questions in your group, ma. You have to practice these questions because there is no time for discussing all these type of questions. After the completion of my topics, I will discuss all these questions, and I will also give some of the exam papers. Okay, okay. Not for simple, ma'am. Yeah, ma, Sonakshi. This is mainly used for the complex mixture because here the mixture containing different components, and that are mainly separated by the chromatography. Any chromatography technique that is mainly used for the separation of the components present in the mixture only. Okay. Yeah. Good. And then I'm going with the spectroscopy, ma. Go with these questions. If you have any doubts, you can post in your group, or else you can post to my number also. Already in group, my number is there. You can chat with me also. Okay. Yeah. Next, I'm going with the other topic, and that is the spectroscopic techniques. Okay. And what is first of all spectroscopy? In techniques, first of all, we discuss the chromatographic techniques that is mainly used for the separation of the biological molecules. And that means as a life science students, we have to identify, or we have to separate, we have to know the particular composition, or what is the material that is present in the mixture. Means we have to identify the particular components that are present in the sample or in the mixture. And that means here different techniques are used for the separation, or for the purification, or for the identification. In that, majorly this chromatography, and that is a simple technique used for the separation and also for the identification. Okay, whereas the centrifugation technique is also there, that is also mainly based on the sizes or based on densities here. We can separate the different type of particles. And also another technique like electrophoresis is there, based on the charging power or charging nature of the components. Here we can identify the components present in the mixture. Okay. And also the other type of technique is also there for the identification of different biological molecules like DNA, RNA, proteins, and also for the detection of antibodies, antigens, like PCR technique is there, blotting techniques are there, and these are all coming with the techniques that are mainly concerned with the mainly identification, separation, purification of biological molecules. In that, the other technique is also there, that is the spectroscopic technique, and this is mainly based on the interaction between the light and matter, And here the basic terms that are used for the light means here the absorption and emission of light, or the incident or transmission of light. This is mainly based on the absorption power of light and emission of light, or else we can call it as incident light and transmitted light. And based on that, here we can observe what are the type of the components or what are the type of molecules that are present in the mixture. Okay, and this spectroscopy, this is mainly deals with the dispersion of light and other radiation that is caused by the light, and that is mainly focused on a particular object. Okay, and this is mainly based on the wavelength. This is mainly based on the wavelength, because here we are using the light, means the light containing different radiations, and that containing different wavelengths, and based on that wavelength here it is mainly detecting the components. Okay, and this is mainly used for the determination of composition, physical structure, electronic structure, and that are present in the samples or that are present in the mixtures. And this spectroscopy, and this is mainly using instrument, and that is called as the spectrometer. And this spectrometer, that is mainly based on the wavelength powers here, and that is mainly used for the detection of different molecules that are present in the mixture. Okay, in that here in spectroscopy, different type of spectroscopic techniques are there, like NMR spectroscopy is there, mass spectroscopy is there, UV visible spectroscopy is there, and these are mainly based on the radiations. What are the type of radiation, and that are mainly used for the detection, and based on that here these are the type of spectrometer techniques. For example, if we take the NMR spectroscopy, and that is mainly based on the variation in nuclear resonance frequencies, whereas the mass spectrometer, that is mainly based on differences in mass to charge ratios, whereas the optical spectrometer is there, that is mainly based on variation in electromagnetic radiation. And that means depending upon this radiation power and depending upon the frequency levels or the wavelength levels here, the variations are detected that are mainly used for the detection. Okay, and this spectrophotometer, this is mainly depending upon some parameters or some type of interaction that are called as absorption, reflection, scattering. Absorption means at what amount of light that is absorbed by the particle, and that is called as absorption. And next, whereas the reflection means how much of light and that is reflected, and at what wavelength that is reflecting, and depending upon that here the reflection, here we can observe the molecules. Whereas the scattering means here the light radiation, how this is scattered, and the scattering power of that molecule, based on that also here we can detect different type of molecules present in the mixture. And also these are based on the phenomena of fluorescence, phosphorescence. Okay, and that means here how these are emitting the radiation, and that means in the form of phosphorescence phenomenon, fluorescence mean phenomenon. Here we can observe the different molecules that are present in the mixture. And also this is called as the electromagnetic spectra, because it is mainly using the light means that containing the electromagnetic radiations, hence it is also called as the electromagnetic spectrometer. And this is mainly measuring the concentration of different samples based on the light that is absorbed by the sample. Understood ma here? What is the main concept behind the spectrophotometer means? It is mainly based on the light, and that light containing electromagnetic radiations, and that are containing different wavelengths of light. Okay, and this is mainly based on the properties of emission, reflection, absorption reflection, scattering. Okay, and based on these phenomena here, we can observe the molecules. Okay, and that shows the phenomenon of fluorescence, phosphorescence, and also electroluminescence, or for the detection of the light. Here these properties are mainly used. Okay, and what is the main device that is used means spectrophotometer, and the spectroscope means here that is a device and that measures different properties of light, and that is present in a particular range of spectrum. I think you know about the spectrum. VIBGR, if you observe the radiations means VIBGR is there now, that containing different wavelengths, and here that forms a spectrum of light, and that is mainly used for the observation of different molecules, and this is mainly depending upon the intensity of light, how it is passing through the molecules. We can analyze the molecules that are present in the mixture. Okay, and in that here we are using the spectroscopes for the visualization of these light radiations, and this is also using some type of prisms or gratings, and that means for the scattering of light this prism or gratings are used. Okay, and that means we have to determine the chemical composition or physical composition of a molecule, and how it is passing the light through the component, and based on that here we are detecting the components that are present in the mixture. And next, coming to the spectrograph, and this spectrograph, it is also a instrument and that detects the light and separates them by using the different wavelengths or frequencies, and this is mainly used for observing or recording the astronomical spectrums. Okay, and astronomical means here that is mainly used for the observation of stars, like that. Here we can observe the different type of stars by using these astronomics, like sun radiations, and also by for the detection of different eclipses also. Here these astronomical spectrographs are used. Okay, and that means here these are mainly based on the light power. That means here different types of mirrors are used for the observation of the light. Okay, and here the rays that are passing through these mirrors, and that means here we are using like prisms or gratings, and that causes the diffraction of the molecules, and that are causing the different wavelength radiations, and that are detected by some of the detectors, and that causes the analysis of the chemical composition of molecules that are present in a mixture. And next, coming to the spectra. Spectra means here, spectra means that containing different colors that are containing different wavelengths. Okay, and here when the white light is passed through a prism, and that causes the different rays of light. Okay, and that are called as the spectra. And in light, the electromagnetic spectrum is mostly commonly used, and this is mainly used for the detection of the electromagnetic radiation that are absorbed or emitted by a particular object. Okay, and also depending upon the type of spectroscopic units, and these wavelength variations are also should be present, and also distribution of radiance is also different. This is mainly depending upon the what is the function of that particular type of spectroscopic technique. Okay, and in that different type of spectroscopic techniques are there. In that the first one is the absorption spectroscopy, and this absorption spectroscopy is a spectroscopy techniques, and that measures the frequency of wavelengths of particular absorbed light, and that is mainly due to the interaction between the light and sample. And in that here absorbance means, and that causing the absorbance of a particular wavelength, that may be of UV radiation wavelength, or that may be of visible length variation, and depending upon that here different type of absorption spectroscopies are there, like UV spectroscopy and visible spectroscopy are there. Okay, and that means here depending upon the absorption power of the molecules, and that may be differing at different frequencies, and depending upon that here the molecules and that are varying with their composition or with their structure. And that means here this absorption spectra, that is mainly depending upon the atomic and molecular composition. And also here, what is the frequency of light radiation that is absorbed means, that is mainly depending upon the energy difference between the states of the molecules. That means here the molecules that are containing different energy levels or different frequency levels, and that are mainly depending upon the light radiation, and that are forming some absorption line, and that forming the absorption spectrum. And that means here this is the major one that is mainly based on the wavelength, frequencies, energy levels, and that causes the radiations. Okay, and here the amount of radiation that is absorbed in absorption spectra, and that is mainly detected in terms of absorbance. Okay, in absorbance mainly two laws are there. I think you know about the laws of these absorbance, that are of Bayes law and Lambert's law. Bayes law and Lambert's law, the amount of intensity, and that is mainly incident, and that is mainly proportional to the concentration of the molecules and path length also. Okay, and depending upon that here how much of the intensity that is reaching the molecules, and that intensity is measured, and depending upon that here we can determine what is the molecular composition of particular molecules. And what are the steps of that absorption spectroscopy means here? First of all, this is similar to like that of calorimetric technique. I think mostly the biochemistry practicals are based on the calorimetry. And for the quantification values, for the quantification of proteins, for the quantification of nucleic acids, how much concentration of nucleic acids and proteins are present in the mixture means we are using the calorimetry technique. And like that also this spectrometry, and that is similar to that of colorimetry, and that is also based on this Beer-Lambert's law techniques. Okay, and in that first of all the sample has to be taken in a transparent vessel that is called as the cuvettes, and these cuvettes are placed onto the chamber that is placed in spectrometer. And here depending upon the scattering of the light here, the wavelengths, and that is mainly absorbed by the particular molecule, and that is detected in terms of absorbance. Okay, and here the absorbance of the sample, and it is noted in different frequency levels, and that ought to be in the range of 200 to 800 nanometers. That forming a spectrum, and that determines the concentration of the particular sample present in the mixture. And then we will draw the graph, and based on that we can calculate the unknown concentration of a particular component present in the mixture. And these are the steps that are involved in absorption spectroscopy. And what are the uses means? This is mainly used for the quantification procedure. I already told now this is mainly used for the quantification of proteins and quantification of nucleic acids that are present in the mixtures. And this is also applied in remote sensing, which is used for the detection of determination of concentration of different type of HRDS substances, and that causing the interactions, and also for the determination of atomic structure and molecular structure. Okay, and what is the concept behind this absorption spectroscopy means? This is mainly based on the electromagnetic radiations. Understood, ma? Electromagnetic radiation, that may be of UV radiation, that may be of visible radiation, and that causes the determination of the particular components present in the mixture by observing the frequency levels and wavelengths. Okay, and that gives the absorbance values. And here how much of the light, and it is mainly passing through the solution, and that can be determined by using these frequency levels and wavelength levels, and that are detected in terms of absorbance, and that is called as the absorption spectroscopy. Okay, this is mainly used for the determination of atomic and molecular structure of various substances. And next, coming to the astronomical spectroscopy. I have already told what is this astronomical. That is mainly used for the detection of the radiation that are passed in the stars and also in celestial bodies. Okay, and here the spectrum that is produced by these celestial bodies or the stars, and that is not like that of spectrum of light. This is different. Okay, and in that also here the both the absorption and emission spectrum of light, and that is produced through a mirrors or produced through the diffraction gratings, and that can be detected, and that are mainly depending upon the energy levels present in the structure of molecules. And based on these energy levels of these atoms and molecules that are present in object here, we can determine what are the molecules that are present here depending upon the particular wavelength. What is the absorption value of that component, and based on that here we can draw the graph between wavelength and flux of absorption and emission lines. And this is mainly used for the uh, detection of the presence of metals, or depending upon the different type of components that are present in the these stars, that can be detected by this astronomical spectroscopy. And that means here the spectral lines are mainly useful for the indication of the components that are present in these mixtures. Okay, and in this astronomical spectroscopy, the incoming light from the stars that is mainly passed through a device called as a telescope, and that causes a